Hello, welcome to Chapter 1, the Bergen Academy's video course for the Bergen Academy's admission test. Chapter 1, the basic stuff, goes over most of the basic stuff that we need to know in order to answer the easier or basic questions on the test. Now, if a question is considered to be easy, that doesn't mean that you're going to be able to do it on the test. It may be easy because it's something basic or something that you should already know. Maybe from 8th grade, maybe from 7th grade, maybe even from 6th grade. So that's why we call it the basic stuff. But it's all very important, and most of the points that we're going to cover in this chapter are points that you will see on the test. So we need to make sure that you know all of this very, very well. Okay, let's go over the points really quickly. Number 1, we have types of numbers, classification of numbers, their types, place value, ones, tens, hundreds, thousands, and so on. The expanded form of a number, how to order numbers, put them in order from least to greatest or vice versa, rounding whole numbers, divisibility tests, how to find if a certain number is divisible by 2, for example, or 5, or 7, or 6, so on and so forth, without using a calculator, because as you all know, you are not allowed to use a calculator at all on this test. 7, commutative property, then the associative property, distributive property. Number 10, adding and subtracting 0, multiplying and dividing by 0, and multiplying and dividing by 1, numbers 11 and 12. Factors of a number, prime factorization, multiples of a number, number 15, 16, exponents, 17, square roots or radicals, 18, what is a factorial? We're just going to go over this really quickly. Not something essential for the test. Order of operations, very, very important. The number line, absolute value, adding and subtracting with negative numbers, multiplying and dividing with negative numbers, then finally coordinates on a grid. Now, since this is all very basic, we're going to go over these points really quickly. We're not going to waste a lot of time here. However, if there's anything that is not fully understood after we finish the explanation and go over the examples together, please feel free to ask me by sending email anytime, and I'll be glad to answer as soon as I can. Number 1, types of numbers. Now, we basically have these types of numbers, okay, that are shown in the table down here. 1, real numbers, any number, negative or positive, fraction, decimal, whole number, doesn't make a difference. So basically most numbers or any kind of number that we know is considered real number. There is such a thing as imaginary numbers, but something that we do not need to know for this test. Whole numbers are of course not fractions, nor are they decimals. They begin with 0 and positives, no negative numbers. Integers are any whole numbers, positive or negative or 0. Prime numbers are numbers that are only divisible by 1 or themselves. Now, let's go over some of these notes. The number 1 is not a prime number because it is not divisible by 2 numbers. How? A prime number is a number that is divisible by 1 and itself. 2 numbers, 1 and itself. The number 1 is divisible by 1 and itself, which is still 1. So it's only divisible by 1 number, so it's not a prime. 2 is the only even prime number, okay? And of course is the smallest prime number because 1 is not a prime number. 0 is neither positive nor negative. And 0 is an even number. Some of these notes will be very important on the test. As part of your word problems, you may be asked, for example, to find the factors of a certain number, given that these factors have to all be prime numbers. So we need to remember what a prime number is. Okay? You can be asked to find the number of even numbers between 2 numbers, like a certain range. Remember that 0 is an even number, so you have to count it there. Okay, now let's go to the next one, number 2. Number 2, place value. The position or the place of a digit in a number determines the value of the digit it represents. Now, very quickly, if you look at this one right here, you'll find that the 0 underlined is the ones. Then here, it's the tens, hundreds, thousands, 10,000s, 100,000s, and the 1 right here would be the millionth place. Okay, just make sure that you remember the names of each of these place values. So if you have any of them on a word problem, for example, in the test, you don't get mixed up. What is the expanded form? Expanded form of a number is actually very simple. Basically what the expanded form of a number is, it's the sum of the values of each digit of that number. Meaning, if I have the number 345, what is the expanded form of that? It's the hundreds, which is 3, since it's a hundreds, so it's 300, plus the tens, which is 4, since it's a tens, so we multiply by 10, so that's 40, plus the ones, which is 5, since it's a 1, so it's 5 times 1, which is 5. So 345 can be written as 300 plus 40 plus 5. This is called the expanded form of a number. Number 4, ordering. Now, remember, this means less than, this is greater than, this is equals. If I have something like this, that means greater than or equal. Something like this, less than or equal. Okay, number 5. Rounding whole numbers. Very basic. It's explained here in details. Let's just go to the examples really quickly together. If you look at this one, for example, round 118 to the nearest 10. Now, first thing I do is I determine where the tens place is in the question. In the 118, this is the tens. Here, this one here, the second one, the one in the middle. Now, since this is the tens, that means that the number before it stays as it is, the first one, and then the value that I'm rounding to, which is the tens, is either going to stay as it is, 1, or will increase and become 2, depending on the number after it, which is 8. Since 8 is 5 or bigger, that means that the number we are rounding to must go up by 1. So instead of 1, it becomes 2. And what happens to the 8? It becomes a 0. So 118 becomes 120. Okay. Okay. Now, if we look at the next one, rounding 155 to the nearest 10 gives 160. Same thing like the one before. Third one, rounding 502 to the nearest 10 gives 500. Okay, let's take another one. 180 to the nearest 100. Where's the hundreds place? It's the 1. So that means that the 1 right here is going to change. Either it's going to become a 2, or it's going to stay as it is, 1. Since after the 1 we have an 8, so it becomes 200. The one after, rounding 15090 to the nearest 100,000. First thing we do is we find out where the 100,000 place is. Where's the 100,000th place here? Which one? Ones, tens, hundreds, thousands, 10,000s, 100,000s. So this 1 is the one that's either going to stay 1 or change to 2, since the number after it is 5 or bigger, so it changes to 2. Okay, simple. Let's go and do the next point. Okay, now, next one here, number 6, divisibility tests. Now, there are a lot of divisibility tests. We're just going to go over the most important ones, the ones that you'll probably see a lot on the test. Remember, you cannot use a calculator, so you need to know these rules very well. Divisibility by 2. A number is divisible by 2 if the digit in its units position is even. So if the last digit to the right, the ones, okay, units is ones, is either a 0, 2, 4, 6, or 8, an even number, that means the whole number is divisible by 2. 74 is divisible by 2 because the 4 is divisible by 2. This number right here, 335,836, is divisible by 2 because the last digit, 6, is divisible by 2. Now, divisibility by 3. In divisibility by 3, we know that if we add all of the digits we get a sum. If this sum is divisible by 3, then the whole number is divisible by 3. For example, is 267 divisible by 3? How do we know? We add 2 plus 6, 8, 8 plus 7, 15. Is 15 divisible by 3? Yes, 15 is divisible by 3. That means that 267 is divisible by 3. Okay, next one, divisibility by 4. A whole number is divisible by 4 if the number formed by the last 2 digits is divisible by 4. Okay, let me remind you. When is a number divisible by 2? When the last digit, the ones, is an even number. What about 4? When the last 2 numbers are divisible by 4. So if you have a number like this, 3,524, how do we know if it's divisible by 4? We look at the last 2 digits, 24. Is 24 divisible by 4? Yes. 4 times 6 is 24. That means that this whole number, 3524, is divisible by 4. Divisibility by 5. A number is simply divisible by 5 if the last digit, the ones or the units, is 0 or 5. Okay, no other cases for this. Divisibility by 6. A number is divisible by 6 if it is divisible by 2 and divisible by 3. Okay? Divisible by 2 and 3, not 2 or 3. It must be divisible by both 2 and 3. Okay, let's remember together. When is a number divisible by 2? If the last digit, if the ones, is even. When is a number divisible by 3? If we add all of the digits and get a number that is divisible by 3 at the end. So, if I'm looking for something, I want to check if it's divisible by 6. I need to find if it's divisible by 2 or not, and if it's divisible by 3 or not. Which would be easier to start with? Divisibility by 2 or divisibility by 3? Which is easier to check? Divisibility by 2 or divisibility by 3? Okay, perfect. Divisibility by 2. Why? Because divisibility by 2, all we need to do is look at the final digit, the ones position. But divisibility by 3, we need to add all of the numbers, especially if it's a long number, then it's going to take more time. And remember, you cannot use a calculator on the test. So adding a lot of numbers may result in an error. So let's take an example here. Is this number divisible by 6? First thing I do, I check if it's divisible by 2. The last digit is 8, so yes, it is divisible by 2. Is it divisible by 3? Okay, I need to add all the digits, you get 30. Is 30 divisible by 3? Yes, it is. So this number is divisible by both 2 and 3, so it is divisible by 6. However, if you look at another number like this, is it divisible by 6 or not? No, right away. Why? Because the last digit is 3, and 3 is not an even number. That means that 298563 is not divisible by 2. And since it's not divisible by 2, then it's definitely not divisible by 6. Okay, we're almost done here. This is getting a little bit boring, isn't it? Okay, let's see. Divisibility by 8. A whole number is divisible by 8 if the number formed by the last 3 digits is divisible by 2. By 8, sorry. So one more time. It's divisible by 2 if the last digit is even. In other words, 0, 2, 4, 6, 8, and so on. Divisible by 4 if the last 2 digits are divisible by 4. Divisible by 8 if the last 3 digits are divisible by 8. So if I have a huge number like this one, all I need to do is look at the last 3 digits. 160. Is it divisible by 8? Yes, it is. 8 times 20 is 160. That means that all of this number is divisible by 8 as well. Divisibility by 9. Now remember, divisibility by 3, we used to add all of the digits and then check if this sum is divisible by 3 or not. Divisibility by 9 is very similar. We just add all the digits, and if the sum of the digits is divisible by 9, then this number is divisible by 9. Example, 1,377. Is that divisible by 9? Let's check. 1 plus 3, 4. 4 plus 7, 11. 11 plus 7, 18. Is 18 divisible by 9? Yes, it is. 9 times 2 is 18. Last one, divisibility by 10. A whole number is divisible by 10 if the digit in its units position is 0, so it's only divisible by 10 if the last digit is a 0. Other than that, it is not divisible by 10. What is the commutative property? Commutative property, something very simple, we all know, basically says that if you're adding or multiplying, you can switch the order of the numbers being added or multiplied and get the same answer. Meaning that 105 plus 8 is the same as saying 8 plus 105. 15 times 7 times 25 is the same as saying 25 times 15 times 7, or 15 times 25 times 7, or 7 times 25 times 15. At the end, if you're just adding or you're just multiplying, you can change the order without affecting the final answer. The associative property, also for addition and multiplication, says that if you have grouped numbers that are added or multiplied using parentheses, you can still change the order. So 3 plus 10, all between parentheses, plus 6 is the same as 3 only plus 10 plus 6 in parentheses. They will both give you the same final answer. Similarly, 2 times 10 times 7 in parentheses is the same as 2 times 10 in parentheses times 7. Distributive property. Distributive property is very important. One of the basics of algebra. You need to know to answer some of the word problems on the test and some of the just straightforward fill in or just solve for X, for example, questions that you may see on the test, and is very basic for algebra whenever you'll be doing algebra. Now, basically what it says is, if I have something like this, 10 times, and then parentheses 40 plus 3, that's the same as saying 10 times 43, right? Which is 430. But we can open up these parentheses using distributive property by saying 10 times 40, here it is, then we put the plus sign as it is, 10 times 3, here it is. Now, is this the same? Yes. 10 times 40 is 400, plus 10 times 3 is 30. What is 400 plus 30? 430. So here we got 430 at the beginning. 10 times 43 equals 430, not 43. And 400 plus 30 equals 430. So basically the same thing. Okay, now we are not required to know algebra for the test. However, using just some basic algebra rules really helps when solving questions on the Bergen Academy's test. Let's take a small example here. Let's say I have something like this. 3 times x plus 2. And I want to use the distributive property to open this up. How do we do it? First number, 3, outside the parentheses, times the first number in the parentheses. So 3x. Then we put the same sign that's here, so plus. Then again, the number outside, 3, times the number inside the parentheses, second one, 2. So it's 3x plus, what's 3 times 2? 6. Okay, this is basically the distributive property. Number 10, adding and subtracting a 0. Of course, if you add or subtract a 0 to any number, it leaves the number unchanged. 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, 5 minus 0 is 5. Now, this may seem very simple. The reason we have it here is because sometimes, as part of a tricky problem or tricky question, you'll find somewhere in the middle that you need to add or subtract a 0 or something, and you may not remember a fact that is very simple like this. Just make sure that you always remember that adding or subtracting a 0 doesn't change the number. However, multiplying or dividing a number by 0, okay, let's say multiplying first because they're a little bit different. Multiplying a number by 0 always gives you 0. 85 times 0 equals 0. 1,000 times 0 equals 0. 4,000 times 0 equals 0, so on and so forth. Okay, this seems very simple. How can it be on the test? Let me give you an example. Let's say you have a question on the test that says, what is the product? Product means multiplication. What is the product of all integers between -5 and +7? you may be tempted to actually start multiplying every number, -5 times -4 times -3 times -2, again without a calculator. However, if you remember this little note here that a number multiplied by 0 equals 0, you'll find out that between -5 and 7 you have to pass by 0. And since you're multiplying by 0, then the product at the end is going to be a simple 0. Okay, now let's take a look at dividing. If you divide a number by 0, this is undefined. However, if it's 0 divided by a number, that equals 0. One more time. So if I say 0 divided by 5, this equals 0. No problem here. But if I say 5 divided by 0, that doesn't equal 0. It is called undefined. Doesn't make sense. There's no such thing. Okay? So you can never divide by 0, or in other words, you can never have a denominator of 0. You can have a fraction like this, 0 over 3. Works. It equals 0. But 3 over 0? No. No such thing. Okay? Okay. Let's take a look now at number 12. Multiplying and dividing by 1. If you multiply any number or divide any number by 1, you get the same number. So 54 times 1 is 54. 54 divided by 1 is 54. Multiplying or dividing by 1 just gives you the same number. However, 1 divided by a number or 1 over a number is called the reciprocal of the number. So if I ask you, what is the reciprocal of 7? The reciprocal of 7 is 1 over 7. What is the reciprocal of 3? 1 over 3. Number 13. Factors of a number. Basically what factors of a number are, we try, if we have a number like 12 for example, I ask you to find the factors of this number. Now we all know how to find factors. However, on the test, because we don't have much time, sometimes some students are stressed out during the test, which is pretty normal. You may tend to miss one of the factors of a number, especially if the question, which is something that is famous on the test, asks you how many positive factors does 12 have, for example. So basically I'm asking you how many factors there are. So if you miss just one factor, you're going to get a wrong answer, because I want you to tell me how many factors. I'm not asking you if 6 is a factor, for example. That would be too easy. So the best way to do this so we don't forget is we do like this. We say, okay, factors. So first factor of any number is 1. 1 and itself. Why? Because 1 times 12 equals 12. So these are factors, 1 and 12. Then you ask yourself, 2 times what equals 12? 6. So these are 2 factors. Okay. 3 times what equals 12? 4. Very good. 4 times what? 4 times 3. We already have that right here. 5 times what? 5 times nothing. 6 times what? 6 times 2. Okay, so we're done. So what are the factors of 12? The numbers that when multiplied by each other give me 12. So 1, 2, 3, 4, 5, 6. So we have 6 factors. 1, 2, 3, 4, 6, and 12. So this way is it's just easy so that we don't forget any of the factors, especially if we have a bigger number. Sometimes on the test you can get a number, a 3-digit number, for example. How many positive factors does a number 525 have, for example? Okay, to make sure that you don't miss anything, you need to list them this way. Okay, now if we go down to number 14, prime factorization. Basically what prime factorization is we're trying to break down the number into its prime factors only, meaning that the factors have to be prime numbers. The best way to do this is to use the factor tree, which I'm sure all of you know how to do. Simply all we need to do is divide the number we're looking for, 12, by the smallest possible prime number. Now what is the smallest prime number in the world? Is it 1? No, 1 is not a prime number. Okay, so what's the smallest prime number? 2. So first thing, we try to divide 12 by 2. Is 12 divisible by 2? Yes. So that means it's 2 and 6. Now, is 2 a prime number? Yes, it is. So put a square. Now 6. Is 6 a prime number? No, it's not. So we need to break it down again into prime factors. Smallest prime number? 2. Is it divisible by 2? Yes. Is 2 a prime number? Yes. Is 3 a prime number? Yes. So I'm done. Okay. Okay, if I have all prime numbers, I'm done. So what are the prime factors of 12? 2, 2, and 3. Okay, this can be written as 2 times 2 times 3, or as 2 squared, because we have two 2's times each other, times 3. Okay, there's another method to do this other than the factor tree, and you'll find this explained right here in the example. Pretty simple. You can take a look at it later on if you want. Now, basically, how can I find questions on the test dealing with factorization? As we said, you can either have a question that asks you, what are the factors of a number, or how many factors does this number have? Or you can have a question that asks you to find how many prime factors there are, like we just did here, or what the prime factors of a number are, for example, and then you get the multiple choice answers. Now, it's very, very simple, and they know it's simple, okay? So why do they have it on the test? First of all, some of the questions are easy. Some will have what you can call medium level, and some will be a little bit harder. The whole point is that because you have little time and you cannot use a calculator, some of the questions that seem to be easy, like factorization questions, basically rely on how you do the question accurately in a small amount of time. So if you do it really fast, you may not do it so accurately, which would be a problem. And if you do it very slowly and accurately, you still get a problem, because in this case, you might get a right answer, but you're wasting a lot of time. So we need to practice things like factorization, like finding multiples, like prime factorization and stuff like that, because you're going to need to do it on the test. And because it's so simple, you may not be used to doing it in school, okay? Maybe you used to do it a couple years back, but now you don't do it that much, so you may take some extra time on the test doing it, which is something we don't want to happen.